How's it going, everyone? Today we're going to try to solve one of the really popular questions on LeetCode. This is going to be something called the longest palindromic substring. Now, if we look at this question, majority of the people would solve it in various ways that it's kind of brute forcey. But actually, in this episode, I'm going to try to go through something that is a little bit more on the advanced topic. We're still going to try to go through to solve this in the traditional way, but I thought I'd throw a little bit of nice little tricks in there to make you have an ability to solve this in OFN time. Okay, cool. So let's first try to understand the question. Okay, longest palindromic substring. Let's read the question. Given a string S, find the longest palindromic substring in S. You may assume that the maximum length of S is 1000. Cool. So for those who don't know what a palindrome is, it's pretty much something where if you take the midpoint, if you look to your left, you look to your right, everything beside you going out is the same. For example, a word like race car would be a palindrome. Something like A, B, B, A, that's a palindrome because in the middle, between the two A's, you basically see a mirror image of one another, right? Cool. So let's look at a quick example. This is really self-explanatory, you know. The palindrome, the biggest palindrome in here is something in the middle, you know, is 3 of size 3, right? And the next palindrome on this one is of size 2. Cool. Now, I wanted to actually dive deeper into this question because one way to solve these type of questions, what we could do is iterate through each element, and then as you are in a specific element, you can start expanding outwards to see if it's a palindrome or not. Although that can solve the problem, for example, you go here and you expand left and you expand right, you can't expand. Go here, expand left, right, you can't. Go here, you can expand right and left, you go BB, etc., etc. That you can solve it. That's like a brute forcey way, and your time complexity is quite high. Effectively, you're forcing your algorithm to go through the question like twice or n squared in a sense. So we're gonna try to go and review a really cool, more advanced algorithm to solve this question. This algorithm is actually called the Manacher or Manacher. I'm probably pronouncing really horribly, but that's what it's called. And we're gonna actually go through it right now. So let me explain it. I'm gonna try a new different topic. I'll try to bring it up as a presentation to see if you guys like this format more. Okay, so let's begin to look at this algorithm. Let's use an example because examples are always great to explain a difficult concept. So the example I'm giving here is NB, N, NBR, right? By the looks of it, just by eyeballing, we know the longest palindrome contained here is going to be of size 4, right? But in Manacher's, I don't even know what it's called, Manacher's algorithm, what we need to do first is to address the question of whether the string is even or odd. So one of the very first things we would want to do is try to manipulate this string such that, regardless if it's even or odd, we're still going to get the same results, right? So the next step we want to do is, adjust the string. Boom. All right, let's focus on the thing I've highlighted here first. We'll talk about the bottom elements and top later on, but I just basically manipulated the previous string and inserted money signs in between each of the characters. This ensures that, regardless if it's an even or odd string, effectively I can still solve this problem, right? It doesn't matter. Cool. So once we have that, what we also need to do is create an array that basically tracks what are the longest palindromes as we go along on this adjusted string, right? Cool. And the next thing in this algorithm that we need to really focus on is the concept of mirroring. I'll dive deeper as we go along this example, and you'll probably get a reference of what I'm talking about. But that's something that you have to think where, as an example, if I take a random figure like n, the mirror value for this would be something like this will be their n prime. I won't dive into it until we get to that point, but let's continue with this example. So one of the requirements we need to do is iterate through this string and do a series of checks, right? Our first check to see is that, okay, at I equal to 0 at the beginning point, let's set our center point, which is the center of our longest palindrome, and to 0, and also let's move our I to its beginning position, right? So our first task is to check, okay, well, how many times can I expand right and left and such that I'm still a palindrome? In this case, it's 0, right? So that's fine, that's simple. You basically update this to 0. Cool. Now the next step we need to do is move the I to the next level, right? In here, we're gonna look at, okay, well, is my longest palindrome 0? Not really, because my left and right, I could still expand, right? So once I find a palindrome that is of size that's greater than my previous one, well, let's set the center to equal to this n and update this value to 1. Now, one of the things that we need to keep track of in this algorithm is an idea of our rightmost boundary, right? Or what is your boundary on your most thinking on ahead of you? What I mean by that is that we may need to create a flag R on top of this particular index. I'll dive deeper into that later, but we'll just go into that. So, cool. We set a flag here because once you have this right flag, that's one indicator when we can check, okay, well, if we should repeat something or not, right? I'll go through an example what I mean. So this palindrome is satisfied. So what are we going to do next, right? We're going to go in here and check, okay, well, is this going to be a palindrome? Well, not really, because you're sitting on top of R, your rightmost boundary, and there's no really thing that you can look over here. Although you could look at this one that looks the same, but you know that doesn't tell you much. So I'm just gonna go, okay, well, this is not a palindrome, so I'm gonna keep it as like 0. It doesn't do anything to me, right? So I'm gonna go move my thing, keep going along, keep expanding. So I'm here right now, right? I'm B. So what happens here? So on B, I'm already above my my R, which is gonna be like, okay, well, if we expand left and right, our longest palindrome in this case is gonna be 1, 2, 3, 1, 2, 3. 3, right? This is our longest palindrome. We're going to change it to 3, but we're going to also move what I said before, this to the rightmost flag, right? And then I'm going to set this particular element, my center, into my longest segment. Cool. So that's relatively simple, right? Nothing difficult here. But this is where the power begins when we move on to the next step. So when we go in here, move along the I again. If I check if my I is less than my right boundary, right? What can I do here in a sense? So we know that the palindrome on I, if this was my center, the maximum this can be would either equal to the minimum of what my counterpart would be, which is this one, which is 0, or the boundary of what my right would be, right? Because that's like the attribute of a palindrome, right? Your left will equal to your right. So therefore, your little brother or little partner here should be equal to what you have as at the very least, right? So what we can do right now is see like, okay, can I expand? In this case, if it's 0 or R minus my position 2, if it's 0 or 2, the minimum of those two elements, well, I'm gonna take 0 as my position. Cool. And then I'm gonna go check, if my left and right would actually do anything. Well, in this case, 0 is probably my right solution. Great. Let's move on along. Okay, cool. So in this case, same thing, less than R, check in here. Your counterpart over here is this 1. And we know that, okay, it can be a 1. We could insert that either R minus I or N, they're both equal to 1. So we're gonna actually say, all right, let's keep this as 1. Great. All right, so the next step is gonna move on to here when we're on top of R. Right? Once we're here, we're gonna go check out, okay, well, I can't check if it's my right boundary anymore because I'm on top of it. So what do I need to do? Well, we're gonna start checking left and right, and start expanding beyond that. So I could expand. It seems like, okay, well, I could expand all the way down to 4, right? So we're going to update this number to 4 and put this on the right boundary to this particular element and ensure that this comes in here. Great. Now we can continue along and move along in this element again and effectively go and check if my I is less than R. It is less than R. I'm going to go check over here of less, it's going to be 1 or 2. The less of those two, I'm going to take this as 1. Oops, not that value. Oops. I'm going to change that to 1. Great. And then I'm going to effectively see if it is the case, which it is the case. Great, because I could start from these two variables. That's great. And expand doesn't make sense and move along. Cool. Now I am going to ensure that check on this particular value. So it's going to be 0 or 2. Take the 0 and then check left and right. Of course, it's 0. Go on to B. B over here is going to be either 3 or 1. This is an interesting one. So it could be 3 or 1. So I'm going to make sure that I'm going to go, okay, I'm going to change it to 1 because I'm taking the less of the two, which is the case in here. Great. We go into here. Boom, same case. I'm on top of it. I can check left and right. I can't go anywhere. That's fine. So my boundary just stays the same, doesn't do anything. My new center is not the same. And then boom, keep going along on my right. Cool. And then update this particular value to here, move this to the center, and boom, this is going to be my value of 1, right? So by doing this, we keep track of our maximum palindrome on this way, and from this, we can actually solve the problem really quickly. Just read the longest one, and then there's our palindrome. So let's go into some code, and we'll be able to understand a little bit more. All right, we're back at the code. All right, let's try to solve this. So one of the first things, remember I referenced before, what we need to do is to adjust the string to accommodate for the edge cases of even and odd numbers. So let's do that. I'm gonna go const equals to a, I'm gonna call this like new string will equal to, I'm gonna write a helper function because here's a actually pro tip. If you were to go through an interview, and if you know you need to do something but you don't have time to do it, you could explain to the interviewer what you're trying to do and use a helper function to return the result that you want. So for example, in here, I'm going to get something called get modified string and passing the s. And you can let the interviewer know that, okay, what this really does is just add money signs to the string that you're interested, and so on and so forth. Cool. This will save a lot of time for you, and if you have time at the end of the interview, you can actually write this equation out. But for now, we're just gonna go and create this helper function. I will write that segment later on, but for now, we understand that, okay, this basically creates those hashes there. The next thing we want to do is to create that p function. You could be p array, which I'm going to call p is a new array of size new string dot length, right? And then I'm gonna fill it with zeros. So what this really does is like creating the equal size of that particular string, filling it with zeros. Great. Now my next step, remember what I said before in my presentation, that we need to keep track of a few things. We need to keep track of where our center is, and we also need to keep track of where the right boundary would be, right? So let's do that. Let's center be 0 and let right boundary equal to 0 for now, because we start from 0. Great. Cool. Now here's the fun part. Now we're going to actually start iterating through the character. So we're going to do that for let I equal to 0 and I is going to be less than the new string dot length, and I is gonna plus plus, right? Cool. Okay, so what are we gonna do here? So one of the things that we need to keep track of is the center of where, you know, where we have to mirror. Okay, where's our index, the mirrored index. So remember when I was looking back earlier and talking about, okay, well, let me go back to an example. So when we're looking at this, the mirror value is here. Well, if we have the center point here and we want to find the index of its mirror, it's basically the same thing as center, it's basically center minus this minus the center. You'll get a value, and then you bring it back in here. So let's get back in here. So the equation is relatively simple. It's gonna be let the index mirror equal to center minus the index. Actually, might be index minus center. Cool. So that will basically tell me where my my mirror index would be. Okay. So in here it's gonna be 0. Doesn't do anything. That's great. So one of the things we need to do now is to check, well, is my I less than, is it basically on my right boundary, right? So we're gonna have to do check is like if my I is less than my right boundary. If it is the case, I'm gonna update my P of I to equal to my minimum, math.min, of basically what we were saying before, which is the right boundary minus the I, or the P at the mirror value. Index underscore mirror. Well, I could use camel case. That's probably better. JavaScripty. Cool. Great. So let's shrink this over here. Great. Cool. What does this do? It's basically what we were mentioning earlier. We're going to check if the value is less than the right boundary, and then take the less of those two. Great. Now this is where we start doing the expanding game. Okay. So let's go and try to expand left and right. Let's define that first. Let's let left equals to I plus, I'm gonna go and say like, hey, where I'm at right now, oh geez, plus, okay, I'm gonna go and say my P of I position, right, plus 1, right, because I want to go, if I go 1 is right, I'm gonna go 1 ahead of me and 1 behind me, right? So I'll do that. And let's go look at that. Let's go here, go on left. The left is like the opposite. I'm gonna minus that value. All right, great. So I know my left and right boundaries, right? So my next thing to do is, well, let's go and, oh God, this spacing is horrible. Sorry, excuse my things. Okay, cool. The next thing to do here is basically check and start expanding my left and right, right? So I'm gonna go and write a quick while loop while my right is less than the length new string dot length. So basically I won't expand beyond my right boundary, and my left is greater than or equal to 0. And also my new string at the left position is equal to my new string on my right position. Basically, if there's like, if those positions are equal to the same, what I'm gonna do, I'm just gonna increase the value over here by 1, and I'm also gonna expand more on the right and left. So I'm gonna go right plus plus, left minus minus. Great. Okay, cool. So now we have this this thing. Let's go and try to look at, okay, let's go and try to explain this a little bit. Okay, so we've already expanded. That's great. Now what do we do when we hit the boundaries? What we're gonna do in here is gonna go like, basically check if my I position plus my P at I, right, is gonna be greater than right boundary. Is it gonna be greater than that? If it is, well, I'm gonna go and readjust my center will equal to my I position, right? So I'm saying that if where I'm at, if I'm overlapping the right boundary, or being a little bit more. I'm going to adjust my new center and also set the right boundary to equal to my I plus pli then I. Great. Cool. So this pretty much covers majority of the algorithm. I'm going to paste in some code that I've written before to, to deal with this string here, which I'm going to give me a second. I'm going to paste it in here so I don't have to waste everyone's time. Cool. I could just go constant that equals to the word. Cool. So what this pretty much does is that, adds hashes to the word, and it returns, instead of money, I'm going to use hashes. That's what it does, right? It returns that. But we're not quite done yet, right? Because right now, all we have done is construct a P of I that tells me where is the longest palindrome, right? We still have to return the actual palindrome itself, right? So one of the things we need to do is start doing that. So last bits of stuff is going to go and see, like, what is the maximum length? I'm going to call length. Well, math.max, and I'm going to spread every element on P to identify what the maximum length is, and let the index of that will be P index of length. Cool. Now we have the maximum length, and we know when the index of that would be. I'm going to start returning the new string dot substring, and I'm going to go and define it as my index minus length plus 1 and length. Sorry, I need some water here. Index plus length. Cool. Once we have that substring of that total substring from the beginning to end for the longest air segment, I'm going to make sure I get rid of those hashtags. So I'm going to go split hashtag. Great. Jeez, come on. Cooperate. Okay, I get rid of those hashtags, and I'm going to join the string again. Cool. By doing this, effectively, I should have solved the problem. There is an edge case that, I want to deal, not edge case, but I wanted to, not have to deal with all this stuff if my string is size 1. So I'm going to do it in here. If my s the length is going to be less than 1, which is, it can be an edge case. I'm just going to return s, which is fine. Cool. So I think this will solve our problem. So let's see if it actually works. Great, accepted, and it's 100% beating everybody else. So I hope everybody understands this. I know this is a little bit more complicated algorithm to think about. However, the results are here. It's fast. I beat everybody, and I just did it live. That's pretty cool. And yeah, so that's it. Hope you guys hit that subscribe, hit that bell, give me a like, give me a comment. Let me know if you like this new format of me explaining things on the PowerPoint. I know I'm just trying to do it as one take as much as I can. I'm trying to not edit as much as possible so you get the raw deal, or you see the struggle I experience. Because not everyone's perfect. I know videos, you can sometimes make it perfect. However, I want to give you the real deal. So stay tuned for the next episode. Thanks for attending. Bye-bye.